physically, so that then it's a lot easier to keep those antennas pointed properly.
So this thing has some type of gyroscope that keeps it.
It does it in a couple different ways. It actually uses accelerometers that are sensing how fast it's the inertia of the speed that it's moving at. And then it also uses the GPS antennas. You'll notice there's offset GPS antennas. So what we do is we take this coordinate, draw a line. Now we know which way we're pointed. And when we know that, we know about every second we get that updated. So as we're spinning, we know that north is always north, so we just make an adjustment based on our orientation to hold that position. Not necessarily north, whatever position that signal is found at.
So if this thing were on a ship and if it were rough seas, this thing reasonably could keep focused in on it.
Yeah, up to about 8 degrees a second. So a big ship.
Is 8 degrees a real rough seas?
That's a real small boat, really. And so that's the other thing, the factor of scale that you run into is on a big boat, 2-foot waves, it's only going to move at about 2 or 3 degrees. But if you're on a 12, 15-foot boat and you have 2-foot seas, you're going to be moving 25 degrees as those waves kind of knock you back and forth. So the scale and the weight and the displacement of the ship all come into play for how much up at the top of the mast that thing is actually swinging around. But yeah, about 8 degrees a second. So I mean, you could get up into 4 or 5-foot seas on a couple 100-foot boat. Before it would start to just, but I mean at that point the seas are rough enough, I don't know how much production you're really going to be doing at that point because you're batting down a hatch.